Okay, can everyone hear me? Yes. Okay, sounds good. Yeah, welcome to this session on OpenTelemetry. I hope I remember to be switching. So I have like this teleprompter with me and my slides here. Yeah, so Hope, like she said, I'm a software engineer at Microsoft. I work in a team where we manage Microsoft's cloud infrastructure. And outside of my day job, I love to encourage people to embrace more observability practices. And one of the ways I do that is being a member of the OpenTelemetry End User SIG, Special Interest Group, where we encourage and help end users like you and me to be successful in their OpenTelemetry adoption journey. And when I'm not working or advocating for observability, I love to be outdoors, whether cycling, hiking, or just enjoying nature. So let's kickstart this session with a journey down memory lane to the very beginning where we had software developers. These software developers were always in this constant bug fix mode where they were always, fixing a bug only to introduce another bug. And debugging was not one of the best experiences they always face. There's always this, nightmare when it comes to debugging because you don't have enough tools to help you with this debugging. Is either you have to rely on print statements or console logs spread around your code because you're trying to understand your code flows. And when issues are reported to you, you don't even know where to start looking or start troubleshooting this issue from. Also, when we develop systems and applications, once they go into production, they become this mysterious black box to you that you have no idea what is going on in the application. You don't know what is happening there. And it becomes very, very, challenging to understand how those systems are working or even performing at all. And then when issues are even occurring in that application, you are not aware of them until maybe they are reported to you by customers. So as scary as this may sound, does this sound familiar? But then we had APM tools. APM tool stands for Application Performance Monitoring. These APM tools helped us to be able to monitor the health and performance of our applications based on predefined thresholds and KPIs. So this way we could watch out for predictable issues. We could get alerted when something is wrong with the system. We are able to be aware of issues at least before they are reported by customers. So in some sense, this was sort of helpful because at least you could get paged, you could get some sort of alerting, some sort of monitoring and reporting. But then monitoring alone was just not enough, right? We needed something that could help us to get a deeper insight into how our applications were behaving. Because again, we don't just want our application to be this mysterious black box that is just out there once it gets into production. You want to understand what is going on inside our application. And especially as we started to have more and more, microservices being developed, we wanted to understand how these services were communicating with each other. We just didn't want to be alerted when there was an issue. We wanted to be able to have the right tools to be able to root cause and fix issues as soon as possible, right? So monitoring was just not enough. We needed something better than monitoring, and that brought about observability. So I'm going to take a quick pause, and I would like to know, is there anyone familiar or who is familiar with the term observability? Just to have a feel of those I'm talking. Okay. That's quite nice. So I'm talking with a familiar room. Okay. So, well, just in case if anyone is not familiar with observability, I like to define observability as the ability to understand the internal state of a system based on the data it generates. So essentially what is happening is that I'm trying to understand what is happening inside of my system based on what is coming out of that system, right? So we are trying to use the data or the telemetry data we are gathering from our system to get insight into what is happening inside our system. So it no longer becomes that mysterious black box to us. And what type of telemetry data are we trying to gather, right? We have several telemetry data you can collect. Today, that pool is expanding as time goes on. We've always had the general types, which is traces, metrics, logs. But right now, we are beginning to have more and more telemetry data being added. We have profiling, we have events, and that is always expanding. We continue to expand. But generally around traces, metrics, and log, we have traces that allows you to know a journey or the journey of a request as it goes through the system. This is very useful in identifying and pinpointing where a problem is in an application. You get to know what exact component or what exact service is actually, causing the problem. And metrics, which you can use to, get measurements and data that happens over a period of time. This is very, very good in showing trends. You can know that, something that has been healthy before is beginning to decline, so obviously something is wrong with the system. So this is very good in showing when something is wrong with your application or system. And then we have logs, which gives you the rich data and detailed records of an event, which is always very helpful in knowing what exactly, like you want to get a context around what caused the problem, right? But then we can't just stop at generating this data. We can't just say, we want to collect data alone or have this data. We need to be able to use this data to get insights, to actually, know what exactly is happening. And that's where we have observability tools. So observability tools help us to be able to define and collect our telemetry data. They provide some sort of backend that you can use to store this data, and they provide UI you can use to visualize this data. And we have several of these tools from the open source ones, like Prometheus, which you can use to collect metrics. We have Jaeger and Zipkin you can use for traces. And we have tons of libraries you can use to collect and visualize logs. Right? I know you're probably familiar with some of them, especially Prometheus in the Kubernetes space. And then we have some observability full, platform like New Relic, Grafana, and all those. Those give you that full stack observability out of the box, so you can do much more with that data. So not just even visualizing it, you can be able to get insight from it. You can use it, especially with the world of AI, you can get more out of it. So, but usually what happened was that each of these tools came with their own agents or package or SDK and specifications. So if I wanted to use a particular tool, like Prometheus, for example, I needed to integrate its SDK into my application and then use the specification to collect metrics from my application. So what happens when I want to use multiple tools? I want to use maybe Jaeger, for example, to collect traces. Then I have to do the same thing using Jaeger specification and all that. And then if I want to maybe move to an open source platform as well, I have to do the whole thing again, like updating my code anytime I want to use any of this tool. So with the rise of more and more of these tools and more platform, and as people started to see how important observability was, they started to become a need for, my slide wasn't updated. They started to become a need for observability, right? We wanted to have this standard around how do we instrument our code, how do we collect data from our code, irrespective of the platform we're using. I don't want to have to always do this instrumentation over and over again anytime I want to use a new tool. And that is where OpenTelemetry came into the observability picture. So OpenTelemetry is a combination of two projects, Open Tracing and Open Sensors, that were created when distributed tracing started to become popular. So OpenTelemetry was created as a framework to standardize toolings, APIs, and SDK around how we collect, manage, and export our telemetry data. So this way we don't have to worry about whatever backend tool I'm using or whatever platform tool I'm using. I can just follow a particular standard in collecting and generating my data, and I can always move it to or export it to any platform or tool I want. So generally, OpenTelemetry is comprised of several tools and components, starting with the APIs and SDKs, which are language specific. This provide you that standard around instrumentation. Then we have the OTLP, which is the language protocol, which provides standard around how we transmit data from one place to another. So whether you're transmitting the data from your application to the collector or from the collector to any backend, we have that standard language that is being used. Then we have the collector as well, which provides that flexibility and give you the control over your data. You don't have to give that control to any agent anymore or any platform or tool agent to be able to collect that data. You can now define how you want to send your data to any tool or where you want to send your data. So usually you start by instrumenting your code with the OpenTelemetry API and SDKs, and they come with the specification you need to be able to collect whatever data you want to collect. And then you transport or send this telemetry data to a central component. Something to note here, most times, it is advisable to use the hotel collector because that gives you the utmost flexibility. But then you can decide to still use a particular platform agent at this point and send your data to that point to that agent. So, but with the collector, you get that flexibility because now you can process, transform, you can filter out things out of your data. You can remove personal identifiable data. You can also aggregate data. This is the part where, this is the point where you can do so much more with your data before sending it or exporting it to any observability platform. So now this way you can export to different observability platform as you like. You can export to multiple. You can switch from one observability platform to another without having to do all this restructuring or worry about ever touching your code. Yeah. So the collector is a set of receivers, processors, and exporters. The receivers are the ones that allows you to be able to collect data, whether through push and pull from either your application or even if you had instrumented, if you have applications and systems that were instrumented with existing frameworks before, maybe even open tracing, or even if you had Prometheus before that you had integrated into an application, you can still send or forward those data to the OpenTelemetry collector. And then we have the processors where the magic sort of happens, and you can, batch your data, aggregate data, filter or sample using the processor. Then we now have the exporters that now sort of fan that data out to whether you want to use vendors, you want to send it to maybe another agent or even open source and backend. So this gives you, like I said, that flexibility because now with the exporter, I can decide to send a data I'm having for my test environment to open source tools because I don't want to be paying a lot of money for test environment. And then when it comes to prod environment, I can send that data to observability platforms, right? And I know there is a specific talk on OpenTelemetry collector later today at 4 p.m. So do check it out if you want to learn more about this amazing component. So now with OpenTelemetry, we now have that standard around how we collect our telemetry data. We have the flexibility to be able to use any tool or platform we want. And we get to just instrument our application once. And you can switch or use any multiple platform at any time, anywhere. And now you can define how or where your data is sent. So essentially, you now have that more control over your data as opposed to before when that control was in a particular platform or tool. So I know now we've seen these amazing capabilities of OpenTelemetry. Hopefully I've done a good job to explain what OpenTelemetry essentially is. The next question could be, how do I adopt this in my organization, or how do I use this in my project? Maybe you've been doing this before, or if you've not been doing it at all, it's like, how do I do this? So the first thing I wanted to say is that there is no one size fits all when it comes to adopting OpenTelemetry. Your adoption story can be totally different from another person's adoption story. That's why I'm part of the end user, working group, because it's essentially a huge part of it is essentially how your applications are architected, how your applications are composed together. That defines a huge difference in how you adopt OpenTelemetry and how another person adopts OpenTelemetry. I had done a talk like several weeks back on talking about my adoption story, and I was talking about the different challenges I faced because of what I had thought or expected I would have seen and what I actually faced. Right? So I'm just putting that out there so that you don't feel like, oh, I'm giving a general guideline, but it didn't work for me. So this is just going to be a general guideline, but definitely it could be more complex or as simple as this, depending on how your application is. So a general guideline on an adoption process would probably start from one, you understanding your application. This is like super, super key in the success of your adoption, because you need to understand how your systems have been architected. Are they written in console? Are they console applications, or are they actually, written in, are they API form? Are they asynchronous application? All those different things will play a huge role on what aspects of OpenTelemetry you're going to be using. It will even play a huge role on, the instrumentation or how your instrumentation is going to pan out. Right. The other thing is the development environment of your applications. Where are your applications currently running today? Are they running on bare metal? Are they running on Kubernetes, VMs? So all those things play a huge role on how you're going to adopt OpenTelemetry. So now you've taken a stock of how your application is made, architected, and where it is running. The next thing will now be instrumenting your application. So this is where you install the packages and SDK specific for your services. Again, I'd already mentioned that the APIs and SDKs are language specific. So depending on the language you're running, that would determine the SDKs you're going to be installing and what exactly or what aspect of it you're going to be using. Then this is where you decide if you want to leverage the automatic instrumentation alone. So OpenTelemetry comes with most of the languages today come with some form of automatic instrumentation, in the sense that the SDK itself already has some instrumentation embedded in it. So once, for example, if I have a .NET application, web service application, it already has some form of instrumentation for traces, for example, that allows you to know that, okay, a particular API was called, this was the duration of that API, even without you doing anything, right? So you can run that, start with the automatic instrumentation, and then you can decide that, oh, I don't want some of this automatic instrumentation. You can decide which instrumentation you want or which you don't want. And you can decide to now add manual instrumentation that is specific to your application. Right? Then the next step is now you configuring your OpenTelemetry collector. If you choose to use the OpenTelemetry collector, which is very, very advisable if you want to get that utmost flexibility. So this is where you set up the receivers, where you're going to be receiving, how you're going to be receiving your data from your application, your processors, the different processors you want to have. Do you want to filter out personal identifiable data from your data before you export it, and then the exporters you want to use. So is that these exporters you now define the platform you want to fan your data out to. So this allows us to now shift that burden of whereas at the beginning, whenever you want to make use of any tool, you start with their agent. Right now, you don't have to do that anymore. You do all the instrumentation, and then the platform is plugged in at the very end. So at the exporter is where you define, oh, I want to maybe use Datadog, for example, to collect all my data, or I want to be using Jaeger, for example, to collect my traces. I want to start with open source. So generally, I always recommend that if you are just starting out, like you're just starting, especially if you're just starting out around observability, I recommend using open source tools first, because that way you can see what data is coming out from your system, what exact data you really need. You can fine tune all those things before going to an actual observability platform, because you have to pay money for these platforms and they cost a whole lot of money. So you have to really fine tune your data before eventually going there. And yeah, at the end is now where you now select, okay, determine what actual observability platform you want to use. So I'm going to do a little quick demo. Let me see. Okay, we're still right on time. Still good on time. So a quick demo to just explain this how this adoption journey would be. I know this is again sounding very simple, but it can be very complicated to as simple as this, depending on how your services are created or architected. So I have this, I have this repository that I had created for this demo. Actually, it was created when I was writing, so there was a documentation I wrote recently on OpenTelemetry. It was a .NET, it was around the .NET instrumentation aspects. We were trying to update it to make it more relatable to people. And so while I was writing that documentation was when I created this repository to sort of follow along on the document. So you can check out the repository. I'd linked the documentation there as well, and I linked it to the end of this slide. So essentially in the repository, I added the different folders that gave the progress around when I was working on it. So no instrumentation is where the simple application is. It's a basic application, just a basic .NET application. And then I instrumented it with traces, then instrumenting with metrics, building on top of them, and then I added the collector. So you can like check it out if you want. So basically the application is a sort of simple application. It's a dice application. It has just one API, which is roll the dice. It takes in a player and then the number of rolls the player wants to do. So it also now calls a class, a library, which is by the side. So we wanted to simulate this aspect of having a normal server, a normal server side sort of API, and then having a class library sort of thing. So it calls this library that takes in that number of rows the person wants to have, and then it does this private method as well that it uses to generate a random number. So it generates different sets of random number depending on number of rows. So if you want to roll 6, if you roll 6, then it's going to generate 6 different sets of random numbers. Essentially, that's what it's doing. So going back to my adoption process, the first thing is I needed to instrument the application, right? Now that I know that I have a .NET application and it is a .NET API, like it's a .NET API sort of application. So I want to install the SDKs that are specific to my application. Again, I said the APIs and the SDKs are language specific. And the documentation is very, very helpful in giving you all the details you need regarding that language. So you just go to the language you are working with, and then you have all the data about the APIs, the SDKs you need that can help you do as much as you want. So now, I've installed the SDKs that I need. The first two is the different exporters I'll be using. And I'm exporting to the console just for me to see, and then exporting via OTLP, which is going to connect to the connector later. And the other two are specific to the language, one for the automatic instrumentation and another around language. So next, I initialized the SDK. This is like, I know too many data. I would recommend you check out the documentation. It sort of explains all of this. So I had something to note that I had pointed out, the fact that I'm exporting via OTLP, and I'm exporting to this particular endpoint, which is where my collector is going to be running. Same thing for metrics. And then, I'm trying to highlight some sort of API, like the trace API in .NET. So now this is .NET. .NET likes to be very, very extra. We don't use the concept of traces and spans in .NET. Traces, I think, are called activity sources, and then the spans are called activities. So, okay. So I'd set up the traces or the activity source in this case. I created a new library called instrumentation, and that was where we did the setting up of the activity sources. And so for the trace API, this is me just generating a particular span or activity in this case to say I've started rolling the dice, or I'm starting the dice, and then I've done that in several aspects of the code as well. And then for the metrics, this is me creating a counter, creating a meter for the metrics. So I want to keep count of the number of times a number is rolled. I know a dice is running from 1 to 6, right? So whenever a particular number is being rolled, I want to keep track of that number so we know number that is actually rolled multiple times, right? So here I'd just created a meter, and at this point had now started to add to the counter. So when that number is generated, just add 1 to that counter, and I'm keeping track of that counter. I know this sounds simple, but in your code, you could use metrics for different things. You can use it to keep track of maybe the health of a particular resource, keep track of the number of times a particular thing is being created, all those kind of things. So, and then the collector config, this is me defining the receivers, the processors, I didn't do so much, and then the exporter. So you would see here where I, set up my receiver as, I'm just receiving from the OTLP protocol, which I defined in my application already. And then here it is exporting to Jaeger and Prometheus. And in the service aspect, you see where I tied everything together, where for traces, I'm receiving from OTLP, I'm just doing it simple processing, and then I'm exporting it to OTLP and Jaeger. And then metrics as well, you see where I'm exporting it to Prometheus. So generally, what I've done is that my application is running as a container, and the container, every single thing is also running as a container. So that way, each of them are talking to each other in this container space. So at the end of the day, if I run my application, what happens is that I get to be able to see the trace. And the first trace you see there, which is roll dice, is not something I added to my code. That's something I got automatically from the automatic instrumentation, that just says, I know an API is called, and I'm telling you the length of that, how long the API took. So the other aspects had the manual instrumentation I did. The start dice were the one I showed earlier, and then some other instrumentation I've done. So you can see that both the automatic instrumentation that came with my SDK and the manual ones I did, they were able to sort of connect together without doing so much. So, and then for the metrics, this is Prometheus, where it showed me that graph of how each number was being called, and at what points they were being generated, or which of them was getting most of the calls. Yeah, and with that is the end of my talk. Oh, still not updated. I'm sorry, yeah, my slide was this is. So, do we have any time for any question?
We have a minute and a half for questions.
Okay.
Oh,
Okay.
there it is.
Hi. So I have hundreds of clusters, a lot of different clouds,
Okay.
a lot of different regions everywhere. I want to start adopting OpenTelemetry
Nice.
organization. Do you suggest one collector or one collector per cluster? I've looked online, I've done a lot of research, but nobody really. I know the differences, the pros and the cons.
Yeah.
Is there anything that you like better than the other?
Good question. Actually, the best person to answer you is sitting by your side. So it's like, yeah. So, I mean, for me, I would say it depends on the number of data you are getting from your application, right? So generally, I would start out with one collector, because again, you need to get a feel of what data is coming out from your system, and then based on that, you can now determine if you really need to create multiple collectors. So it's usually very specific to you. As I say, your adoption is specific, but it's always good to have an understanding on why you need to do certain things, right?
So my question is, if you're in a situation where there is some instrumentation installed as another APM vendor, do you have recommendations for helping, not necessarily transition away, but like use that in parallel with starting to implement OpenTelemetry in the same cluster?
Yeah. If you've been instrumenting before and using a particular vendor, technically it's going to be like a slow transition, right? At the end of the day, most likely that vendor is integrating with OpenTelemetry in some sort, right? So they would probably already provide some way where you can start exporting that data into other sort of tools, or other sort of, they provide some sort of, like they would provide that OTLP language specific thing, that OTLP protocol you can use to now export to maybe a collector. You can be receiving that data from them, and then exporting it to some place you want to put it, and like then you can do that slow transition from having that hard or hard knitted or tightly that being tightly coupled with the platform as opposed to being loosely coupled from let me just get the data directly from my application into a particular collector and then exporting it to the platform. I don't know if that
Thank you
makes
so
sense.
much.
Yeah.